Hello guys, welcome to Backbencher Studies channel. In last video, we have discussed block diagram, reduction rules and representation of a system in block diagram method or block diagram technique. So in this tutorial or in this video, we'll be discussing what how we can simplify block diagrams. So here is a procedure. If we follow this procedure, you will be definitely solving a big block diagrams, and we can easily reduce that into a simple kind of a system. So let us proceed how to do that. So here are the rules you can use. So first you have to check whether there are blocks in series or blocks in parallel. If you have, just apply the formulas and you are good to go to solve to the next step. If you don't have any series or parallel steps, you have to check for feedback loops. Either it is a positive feedback or negative feedback or unity feedback. You can anything which will be present in the diagram, you should see and you should solve them first based on the formula. If these three are not present in our block diagram kind of thing, we can go for shifting of takeoff point or a summing point either towards right or towards left, so as to make these blocks in series or blocks in parallel or blocks in feedback. If not possible, then we can try shifting, or we can try interchanging of summing points or any other points. So if we are not having any, if you are not having, if it is not possible to shift any takeoff point, then we can have another procedure kind of thing, we can where we can solve this problem by equations. So let us see how we will be doing that. So here is a problem. So we have to find the overall transfer function of this flow diagram. So we have here the input and we have here the output kind of thing. And this is so what is being discussed here is, first check for the blocks in series or blocks in parallel. So we have three blocks in which are in series, and we have three blocks which are in parallel. So we can simplify that. So a blocks in series will be the gains will be multiplied, and blocks in parallel the gains will be added. So first let us simplify that one. So on simplifying this, these blocks in series will be a single block of gain, overall gain, multiplication of these three, and vice. And same here, the parallel blocks are simplified, not simplified, but in the next step you can do that. So moving on to next step. So here we have simplified this parallel kind of thing, and you can see now that here is a positive feedback loop. We can solve g over 1 plus g 1 minus gh. Using that formula we can solve this loop, and next step we can easily solve that loop. So, and this effective block, which is the positive feedback, is in series with this block. And if we multiply these two gains, and this will be a negative feedback of H1 feedback system gain. And if we simplify that thing, and upon simplification we have this equation, which is the overall transfer function. So this is how we simplify a complex block diagram into a simple overall transfer function. So let's move on to the next question. So find the overall transfer function of this. So upon observing this figure, we have a series combination. So what we have discussed is, first look for series or parallel connections. So we have a series combination of blocks here. So let us simplify this thing. And we have a parallel combination blocks here, G3 and G4. So let us simplify these two. We have what is called this. So we have simplified this G1 and G2 and G3 plus G4. So we have a negative feedback loop, and we have a negative feedback loop. So let us simplify. So how to do that? We already know G by 1 plus GH. So where G is G1 and G2 and H is H1. So if we substitute and simplify that thing, we get this. So what we have done is simplification of this negative feedback loop system, and here we have what is called this thing. So what we have done is another thing is that if we shift this takeoff point to here, we have a positive feedback loop kind of thing. So shifting this takeoff point over here and dividing this gain over G5 with this block gain. So following that convention and rule, we have shifted this thing. So here we have done two things, that is the simplification of negative feedback loop, and we have shifted this takeoff point to this to the right against this block. So we have divided this with this gain G5 over here. So upon moving to the next step, what we have done is, we have actually these two blocks in series. So what we have done is we have made that in using series formula, and we arrived upon this kind of thing. So this diagram, so if we split this into two, so we can split this into this take of into two. Basically it is the same signal which is flowing in these three lines. So we can split this into two. Upon splitting this, we have a negative feedback kind of thing over here, and negative feedback kind of thing over here. And upon solving this negative feedback with G over 1 plus GH, we have the following transfer function, and these two are in series, and these two combination with this H2 by G5, we have a positive feedback. So G over 1 minus GH, using that formula, we can simplify the overall transfer function. So here we have just simplified this series connection, and we have the overall transfer function like this. So this is the way how we will be solving these simplification of block diagram problems. So moving on to next question, which is the gate question. So how to solve this? So we can solve this. So this is a pretty straightforward kind of thing. So we have this input and we have this output. So we have these two blocks, and it is not mentioned here in the question, but we know that these two are negative feedback system. It is given in the question. I'm sorry, I didn't mention. So these two are negative feedback system. So this is the G kind of thing, and this is the H. So if we use the formula for negative feedback, G over 1 plus GH, we can get and we can solve with that. And this the overall outer part is the unity feedback system. So if we solve by using H, we can solve this as the overall transfer function as 10 by 10 by s square, 10 plus s square plus 11s. So this is how we will solve the questions. So in the next class, we will be solving how to use or how to use another method to solve block diagram technique. So we have used all these rules, and if we are not able to do this block diagram rules, then what to do? That will be seeing in the next lecture. So thank you guys, thank you for your time. uh, I'll be stopping here. If you like this video and if you are new to our channel, please do subscribe the channel.